talk about several things today, but it's all kind of in the name angles and angle measures. Okay, that's what we're talking about. So first of all, let's talk about when we talk about a coordinate plane, how these angles even exist, where they are, and what we're talking about. And I think most of you guys are pretty familiar with this. Like if you look over here at your coordinate plane, your 0 degree side is going to be right here, the positive x value. All the angles, it's not working. Love technology. Here it comes. All right, now we're rolling. So all the angle measures that we're going to talk about today, they begin from this location, okay? This is the positive x-axis. And when we talk about these different angles today, the ray that's on that x-axis is called the initial side. But again, to discuss some things that I know you guys are familiar with, this angle right here going straight up, what does it represent? 90 degrees, right? Y'all know that. So this one right here represents what? Go ahead and say it. 180 degrees. And then this one? 270. And this one could be one of two things, right? It could be 0 degrees like it's called, but technically it could also be what? 360 degrees. One full revolution, which we're going to talk about that in just a second. Now, when we talk about a specific angle, and we go to this coordinate plane, and we go and we draw that angle, we're going to draw the other ray, the final ray that makes that angle up. So we call that the terminal side. The terminal side. The initial side is always where? The initial side is always where? Positive x. And then, of course, the terminal ray is going to be where it defines that specific angle. Okay, now, if we're talking about going around in a counterclockwise motion, so we start right here at 0 degrees, and we go in a counterclockwise motion, we are talking specifically about positive angle measures. Positive. But if we start at this same spot and we go around the opposite direction, guess what we're going to talk about when we talk about counterclockwise angles? We're going to talk about negative angle measures. Negative. And like I said a second ago, something that you guys have been familiar with for a long time. One full revolution is how many degrees? 360 degrees. Okay? All right. Pretty easy stuff, right? Yeah, this is easy, right? That's what I want to hear from you. Okay, so we're going to go and we're going to draw the terminal side of a 75-degree angle, okay? So how would y'all describe where it's at? Could you tell me what quadrant it's in? 75 degrees?
Positive, positive.
It's in positive, positive. That's quadrant 1, right? So about where is it? Is it closer to the x-axis? Is it closer to the y-axis? What? It's definitely closer to the y-axis, right? Because the y-axis is what? 90. So it's how far from 90 degrees? It's just 15 degrees. So let's say it's about right in here. Does that look pretty good? So we started right here and we went up 75 degrees. That is a 75-degree angle right there. That's pretty easy, right? Okay, what about negative 160 though? What do I do here? Well, I'm not going counterclockwise, right? I'm going what?
Clockwise.
So do I go past negative 90?
Yes.
Do I go past negative 180?
No.
No. I stop just shy of negative 180, maybe right in here. And this is my negative 160-degree angle. You follow? It's pretty easy, right? That's negative 160. And then how 430? What do I do about that?
Don't you put like a whatever it would be in subtracted by 100? So like
Why 100?
Because there's 360 in a full circle.
Okay.
So you find wherever it would be on a 360. So you go counterclockwise.
Counterclockwise.
So you hit 360, and from 360, you would subtract 430 by 360. And that's
Okay, there it is. I didn't know where the 100 was coming from.
I don't know where.
So we're going to subtract 430 minus 360. What is 430 minus 360? And I'm going to draw a 70-degree angle here. That is 430 degrees. We went all the way around, one full revolution, 360 degrees, and then we went all the way back up 70 more. That's a 430-degree angle. Now, what you guys said, we're going to come back to that concept here in just a second. But what Aiden did there is exactly right. Is there really such thing as a 430-degree angle? I mean, really, there's not. Think about your coordinate plane. It's limited to how many degrees? 360. Some people would say 359. Because what happens when you get all the way to 360? Technically, you're back to zero. But yeah, one full revolution is 360 degrees. That's what you're limited to. So a 430-degree angle really doesn't even exist. So we went past 360, 70 more. And we knew that by going 430 minus 360. That's a concept that we're going to talk about here in just a few minutes. So hang on to that. We'll come back to it, okay? Now, when we talk about the angles that exist in a coordinate plane, we sometimes compare this to this thing called a unit circle, which is what you see right here on the left. That's a unit circle, a unit circle. In fact, if we had time, we would do some more things with a unit circle, but we just don't have time. But anyways, here's one of the things that you need to know. One full rotation is 360 degrees, but in radians, because they are very related, in radians, one full revolution is the same value as 2 pi. And here's how you might remember this. Remember circumference of a circle? 2 pi r, circumference. So it's all related to that, as you can read this on your own, what it says. Now, if 360 degrees is 2 pi, what would be the value of 180 degrees? Pi. Pi. Now, let me take you back to something real quick from your past that I know that you're familiar with. And let me just keep it on my paper here. This is something that's just kind of extra. So here's the thing. Y'all remember conversions? Conversions? Like, for example, if I said, hey, I want you to change 3 feet to inches. Do y'all remember how you would do that?
You do like 12 foot.
12 times 3.
Why 12 times 3?
Because there's 12 inches in 1 foot.
So what we're trying to do is we're trying to get rid of feet, right? And we're trying to change it over 2 inches. So sure enough, 1 foot equals 12 inches. So we would multiply by 12 over 1. Why? Well, because if I have feet on top of feet, what do? They'll cancel out, and now that it allows it to turn it into what? My answer is going to end up being in what unit?
Inches.
Yeah, because the feet cancel, right? So 3 times 12 equals. So we had to use the equivalent of 1 foot being 12 inches in order to convert. Okay, here's the point. Let's go back up here. When it comes to converting, so I have a degree measure and I want to convert it to radians. The way that I convert it is using the fact that 180 degrees is equivalent to pi in radians. So if I want to change degrees to radians, I'm going to take my degree measure and multiply it by pi over 180. That's my conversion. Just like multiplying 12 inches by 1 foot. That's my conversion. Pi radians to 180 degrees is my what? Conversion. Okay, so if I wanted to go the opposite direction, they give it to me in radians and they want me to write it in degrees. Well, radians degrees, I take the radians and I multiply it by 180 over pi. Exact opposite, okay? Or instead of opposite, I should say inverse. Because technically in math, opposite means you change your sign. So your reciprocal here is what we're really talking about. So look at 30 degrees. I want to convert degrees to radians. So what does it say in your notes you need to multiply by? Degrees to radians. Hello? Degrees to radians. Multiply by
pi radians.
Pi over 180. Alright, so hang with me here. Do you have a pi button in your calculator? You think I want you to use it right now? No, I don't. I want you to leave radians in terms of pi, meaning treat it like it's a variable, okay? Don't multiply it by it. We're going to just leave it there. Pi is going to be in my answer, so it'll be in terms of pi. So what's my focus really need to be here? Not just 180. 30 over 180. So go to your calculator, go to alpha y equals number 1, and do 30 over 180. 30 over 180 equals 1 over 6. So if I already have the pi there, wouldn't it be 1 pi over 6? But do I really need 1 pi over 6? So I'm just going to write pi over 6.
Because it's 1?
Yeah, because it's just 1 pi. I mean, you're welcome to put 1 pi over 6. It just seems kind of pointless, you know, to have 1 there. Because it's just not needed. So 1 pi over 6 or pi over 6. And that's how you convert degrees to radians. Pretty simple, right? So look at number 5. Again, 150 degrees. What do we need to multiply by? To change it to radians? Pi over 180. We're going to ignore the what? We ignore the pi. That way we leave it in terms of pi. And we're going to focus on what? 150 over 180. What do you get? 5 over 6. So what's it going to be in radians? 5 pi, not r,
not r, sorry.
5 pi over 6. Done. Okay, last one, negative 220. Again, multiply by pi over 180. Leave the pi alone. And let's just focus on negative 220 over 180. Negative 220 over 180. What do you get? Negative 11 pi over 9. Okay? Stop me if you have a question. Anybody have a question?
Is that possible to have a negative on the fraction?
Yeah. Yeah, just like you have, listen, it's all about direction, right? If I have a negative 220 degrees, it means I go clockwise from the positive x-axis. Same thing for negative 11 pi over 9. It just means I go clockwise, right? So positives versus negatives in degrees and radians really just is directional. Positive means I go from the positive x-axis, I go counterclockwise. Negatives, I go clockwise. It's direction, okay? Does that make sense? Okay, now let's go the opposite direction. We want to change radians to degrees. So what do I multiply by instead? The reciprocal, right? What was the reciprocal of 180 over pi? Oh, sorry, pi over 180. 180 over pi. Okay, now you guys have been doing math for a long time. What's the first thing that you see right here that you know could happen? You have a pi in the numerator and a pi in the denominator. What are they going to do to each other? They're gone. So what does my focus really need to be here? Guys, what's my focus need to be here? 4/3 times 180. The pi's gone. So what's 4/3 times 180? So 240 degrees. 240 degrees. Does that make sense, y'all? Okay, look at number 8. Negative 5 pi over 36. What are we going to multiply by? To change it to a degree? 180 over pi. What's going to happen to the pi's? Cancel. So what's our focus? Negative 5 over 36 times 180. Y'all about to make me fall asleep. What's negative 5 over 36 times 180? So negative 25 degrees. And we'll do this last one real quick too. Times 180 over pi. The pi's cancel. So it's 7 over 4 times 180. So 315 degrees. So, y'all feel like you can easily change it from degree to radian, radian to degree? You understand why. It's the difference between talking about the degree, the way you move around a coordinate plane, and the radian, the way you move around a unit circle. Okay? Same concept, just a little different figure. Let's go to the back. Actually, let me go to number 3. Y'all flip over to the back. I know that I put 430 degrees on number 3 earlier, but what was it really? It was really 70, right? So would y'all tell me that 430 degrees is equivalent to 70 degrees? Would you? Yes. You absolutely can tell me that because they're in the same, what L word am I talking about here? They're in the same location. Y'all are killing me. They're in the same location. Okay? That's why they're equivalent. 430 doesn't really exist. 70 does. They're in the same location. How did y'all figure that out? Well, we made one full revolution, 360, and then we said, well, we still got some to go. So we subtracted 360, and that's how we got 70. That is the next concept we're talking about on the top of the second page. They're called coterminal angles. Coterminal angles mean that they might be different looking, but they're in the same, what? Position or location. They're in the same location. So that's the next thing we're going to do. We're going to find coterminal angles. If it's in degree mode, we're going to add and subtract what? If it's in degree mode. How do we do? One full revolution to where we get back to where we just were. We add or subtract what? 360. Okay? That's what puts me right back to where I was. But if it's in radian mode, I'm not going to add 360. I'm going to add and subtract. What's the equivalent of 360? In radians? 2 pi. I'm going to add and subtract 2 pi. Are y'all with me? Or are y'all lethargic and not with me? Alright, so for example, what are my coterminal angles with 65? Well, don't I just need to go, okay, what's 65 plus 360? 425. And what's 65 minus 360?
295.
Negative 295. Those are coterminal angles. Alright, is everybody listening to me? Are these the only coterminal angles? No, I just did one more positive one and one more negative one. What could I keep doing to keep finding more and more coterminal angles?
Adding and subtracting
I could keep on adding or subtracting 360 degrees. We could find a bunch, you know? I just like to find one negative one and one positive one, which leads me to number 11. My angle is 540 degrees. So instead of going crazy big, right off the bat, I'm going to go ahead and subtract 360 to bring it down a little bit. Sometimes, guys, you use coterminal angles to get an angle between 0 and 360. Y'all hear me? One of the purposes of coterminal angles is to take any angle and change it to an angle between 0 and 360. Now, what is 540 minus 360? 180 degrees. And instead of going 540 plus 360, I'm going to, in order to have one positive and one negative one, I'm going to take 180 and I'm going to subtract 360 again from it. So I took a coterminal angle and I subtracted 360 to find another coterminal angle. So I went from a coterminal angle to another coterminal angle. Is that illegal? No, it's fine. I kept subtracting 360. What is 180 minus 360? So the positive and negatives I came up with are positive 180 and negative 180. It's that easy, guys. What about number 12 and 13, though? What are they in? They're in radian. Okay? Radian, which we sometimes would say a fraction. But they're in radian form. So what do I need to add and subtract here?
Pi.
2 pi. Now listen, guys. Treat it like x. Treat it like x. Are you going to go to your calculator and type in 13 pi over 18 plus 2 pi? No, you're going to treat pi like x. If that said 13x over 18 plus 2x, wouldn't you just go to your calculator and go 13 over 18 plus 2? Hello? Wouldn't you do that? So do that and then leave it in terms of pi. So somebody help me out. What's 13 over 18 plus 2? 13 over 18 plus 2.
49 pi.
So my answer in radian form is 49 pi over 18. Does everybody see that? I left it in terms of pi. I treated pi like a variable x. Y'all see that? Okay, one more. Let's do 13 pi over 18 minus 2 pi. Again, leave pi alone. What are we going to do? Type in our calculator. What? Not all at once. We're going to type in our calculator 13 over 18 minus 2. 13 over 18 minus 2 gives me what?
Negative 23 pi over 18.
Negative 23 pi over 18. Okay, questions? Do I have to do another one or we get it? We good? Okay, let's keep moving then. Let's go to the next thing, which sometimes people struggle with the most. And I want to show you guys two things before we really get into this too heavy. One, for reference angles, the first note I want you guys to write is it has to be positive. It has to be positive. Second, it has to be under 90 degrees. Except 90 degrees, 90 degrees. I guess it could be less than or equal to 90 degrees. And the last thing that I want you to jot down here is it has to do with how far it is from the x-axis. Okay? How far it is from the x-axis. Here's the x-axis, guys. The reference angle is how far it is from the x-axis. Y'all understand? Y'all understand those three things? The answer has to be positive, and it has to be less than or equal to 90 degrees. It's all about how far it is from the x-axis. So look at this one right here, 225. 225 degrees. Now again, I know then if I went from here to here, how far did I just go? If I went from here to here, I just went to 180. But if I went all the way to here, I went 270. I went too far, didn't I? So it's somewhere between 180 and 270. So about how far is it from 180? About that far? Does that look pretty good?
That looks like it's halfway.
Well, it should be.
From 270?
What is 270 minus 225? Type in your calculator real quick. 270 minus 225. 45. What's 245 or 225 minus 180? So it's dead middle, right? So listen to me, guys. The reference angle is how far is it from the x-axis? So my reference angle here is talking about that little spot right there. That's my reference angle. You understand? So guys, what is the value of my x-axis right here? What's the value of my x-axis right there?
Negative. Isn't it whatever, 180?
180 degrees. That's the value of my x-axis right there, 180 degrees. So if that angle is 225, we're simply going to go 225 minus 180. That's how far it is from the x-axis right there. 225 minus 180 is what? My reference angle right here is 45 degrees. It's 45 degrees from the x-axis. That's my reference angle. Is that a positive number? Is that a positive number? Is it less than 100 or less than 90 degrees?
Yes.
Okay. Now look at the next one. That's supposed to be negative or positive 310 degrees. Positive 310 degrees. So, right here is 90, right? Right here is 180. Right here is 270. I'm still going, right? How far past 270 do I go?
A little under halfway.
A little under halfway. I go 40 degrees, right? So let's say somewhere around in there. Guys, what's my reference angle? How far is it from what? How far is it from the x-axis? Right there. Now, what's the value of the x-axis right there? 0 or 360. Which one is more useful to me when the measure angle is 310? 360. So if I want to find how far it is from 310, I'm going to simply go 360 minus 310. How far is 310 from 360? So that reference angle is 50 degrees. You understand? This is pretty easy, right? Okay, let's do one right here that's in radian mode. Do y'all know how to graph radians? So what are we going to do? Change it to a degree. Multiply by 180 over pi for me. Right? Isn't that what we were doing earlier? The pi's do what? So y'all are going to go to your calculator and you're going to type in what? What's 2/3 times 180? 120 degrees. Okay, 120 degrees. Where's that at? Well, I go past 90 about 30 degrees, don't I? It's right about there. So, we want to figure out how far is this from the what? X-axis. That's what reference angle means. How far is it from the x-axis? Well, again, look at the x-axis it's touching here. What is this measure right here of the x-axis? 180. But since it's less than 180, shouldn't we subtract it from 180? So what's 180 minus 120? So it is 60 degrees from the x-axis. That is how you find it. So one last thing. Go back over here to this little drawing. In this quadrant right here, as long as your angle measure is a 0 to 360 degree. So if it's a negative, do the coterminal angle. Get the angle between 0 and 360. You hear me? If you want to find your reference angle, get your angle between 0 and 360, and then here's your rules. If it's in here, it is what it is. Think about it. If it's a 40-degree angle in here, what's its reference angle? 40 degrees. If it's a 50 degree, it's 50 degrees. Okay, here's the last three. If it's in quadrant 2, I want you to do 180 minus whatever it is. If it's in quadrant 3, I want you to do whatever it is minus 180. But if it's in quadrant 4, I want you to do 360 minus whatever it is. 360 minus whatever it is. And that's how you find your reference angle. Because those will always tell you how far they are from your what? X-axis. Does everybody understand that? It's so easy, okay? Don't let reference angle be difficult. Sometimes people do. Don't. All right, let's move on to the very last concept here. And it's called the trig functions and how these relate to what we just did on Thursday and Friday. I want you guys to notice when they name a ordered pair, they're giving me an x value and a y value, right? An ordered pair. But we're wanting to talk about that in reference to trigonometry. So here's what I need to know. Whatever this x value is, and whatever this y value is, if I also draw a line from the origin to where that point is, I have a what figure? I have a right triangle. And we're going to be talking about this as far as the reference angle goes right here. So listen to me. In reference to this angle, let me highlight it. In reference to that angle right there, what is this? I heard it. The opposite leg, right? In reference to this angle, what's this? That's the adjacent leg, right? And then what's R? It's your hypotenuse. Therefore, as far as how this relates to the Pythagorean theorem, R squared will equal x squared plus y squared. Okay? Same thing as a squared plus b squared equals c squared. C in this case is your R value. You with me? Alright, so here's how this works. The sign is always opposite, which we said was y over hypotenuse, r. So, for all ordered pairs, x and y, y is going to be your opposite leg. Okay? And then, of course, that would make cosecant r over y. Cosine will be your adjacent leg, which will always be your x value of that ordered pair over r. So secant will be r over x. And then finally, tangent is opposite over adjacent, which is y over x. Cotangent, x over y. So for example, I want you guys to look at this. I think it's important to be able to draw it. It says point P, at 5, -2 is a point on the terminal side of theta. In standard form, find the exact values of the trig functions of theta. So here it is, guys. X is what? 5. I go 5 to the right, correct? 5 to the right. What's y? Y is -2. I go 2 down. 2 down means -2. And then you've got this r value that goes from the origin to the end of that point, right? That is my r. So don't we need to find it? Well, isn't r squared equal to x squared plus y being -2? I put it in parentheses squared. Y'all with me here so far? So doesn't r squared equal r squared equals 5 squared, which is 25, plus negative 2 squared, which is 4. 25 plus 4 is 29. And don't I take the square root of 29, which won't break down? So my r value is the square root of 29. Now, let's answer sine, cosine, tangent. Ready? Sine. Sine is always y over r. What's y, guys?
Negative.
Over square root of 29. So cosecant, what do I do? Somebody say flip it. Flip it. Very good. Cosine, what do I do? Adjacent, which is x over r. What's x?
5.
So 5 over the square root of 29. For secant, flip it. Square root of 29 over 5. And then finally for tangent, opposite over adjacent, y over x. What's y? Over x. So cotangent, we do what? Flip it. Alright, so y'all see anything that needs to be cleaned up a little? According to what we talked about last week? The sine and cosine. I need to multiply by the square root of 29 over the square root of 29 to get that radical out of the denominator. So here's my final answers for those. This one is negative 2 square root of 29 over 29. And this one is 5 square root of 29 over 29. Now, I'm 100% done. So, y'all see that? Does that make sense? Now, we've talked about several things today. That's a bunch, okay? It's a lot. Appreciate you guys staying focused, for being with me, not falling asleep, and writing your notes. This is your assignment, okay? I'm not going to give you a homework assignment for one main reason. Tomorrow, I don't have time to go over it, okay? I just wanted to teach this because you will see it. I know you will see it. In fact, I've seen a question before where it gives you an angle measure, and it says, which of the following are coterminal angles with this angle? If you don't know what a coterminal angle is, there's no way you can get it right. If you know that a coterminal angle, you're just adding 360 and subtracting 360, it's really easy to find the ones that are coterminal, right? So, I've seen these questions, that's why we had to go over it. But anyways, tomorrow, as soon as we come in, we'll get started on that practice test. And then when we're finished with that practice test, we will go over it beginning next week. But it'll take us about 2 days, okay? 2 days to get all the way through it.
So we test next week.
You take your practice test tomorrow and Wednesday. Then we have a whole week of review. And then the next week we take our test on May the 6th.
Okay.
So we have a whole week between.
Oh, it's 10:25.
All right, it's 10:25.